Okay, so in question one, we optimized the calculation of the view and projection matrices with the world matrix. So we calculate our view projection matrix before going into the GPU. We process it all here. And then in our HLSL file, it takes that product so it doesn't have to calculate it here on the GPU. And in question two, very similar. We're generating 5 different cubes on the screen. We get the view projection once, and then for each individual cube's matrix, world matrix, we multiply it by that product. Question 3, we generate the pyramid with the numbers texture. So we get the same texture on all 5 faces. So as you can see, it's all generated there correctly. And then just quickly taking a look at the code, for each of the vertices in the pyramid, we set its position, and then we set its UV mapping. So our UV is all set there. Question 4 is very similar, where we generate the cube that's using the same texture, but each face looks different because they're more specific parts of the texture. So again, same function, we set the position, and then the UV mapping is just a little more specific. Just by taking a look at the picture, you determine what those exact values would be. And then finally, question 5, we implement our shader texture class. So we set it here and we initialize it. We set its context, get the resource sampler with the crate face. And then when we draw the scene, we update the camera matrices and send the world matrix. And then here's the function that we created for that. And then once we run it, we get our crate. And then if we go back into question 3 and also switch over to our unit box and change the texture to the crate. So instead of getting the regular crate texture, we're actually just going to get a brown cube. So the reason that we get this, if we take a look at the code for generating that cube, so when we set the vertices, this is the set function that is called. So in addition to the position and the color, it also sets default values for the UV mapping. So by default, it's set to 0, 0. So whatever texture is being taken as input, it only generates the top left value of that texture. So that's why we only get one single color for the cube and not the whole texture. And then in question 1, I also have some code set up to handle the cube matrix, the 1,000 cubes generated that we were doing in class. I have an unoptimized and an optimized version. I'll go through both of those and show what those look like. So first we just set our shader color to be the one that'll be set to context. And then once we pull this up, we get 1,000 green cubes that show up in a matrix. And then the frame rate should be going up to about 160, 170. So then let's go then and show what the optimized version would look like. And I'll also show the differences between the optimized and the unoptimized here. So taking a look at this, the two key differences between these, in the optimized, we're going to set the context of the model just once before we generate, because since we're using a cube for all of the models, we only need to set context once, so we don't do it every single time we generate a new shape. And then we also, again, as before, we calculate the view and projection matrices once, and then multiply that same product by each cube's individual world matrix instead of recalculating it every single time. So if I just comment out our unoptimized version, and then we run this, we should see a drastic improvement. In the past, I get like about 100 more frames for this one, so we should be getting like 260, 270 frames.